In this video, you'll learn how to construct a 4x4 most perfect magic square for a magic trick or your interest and amusement. Note that in this video, when I refer to a most perfect magic square, I will relax the requirement that it must contain consecutive numbers starting from 1. Let's begin. First, we need to know what a most perfect magic square is. Shown here on the screen is the most perfect magic square with magic sum 34. The magic sum is also known as the magic constant. A most perfect magic square has each row, column, and major diagonal add up to the magic sum as shown. However, most perfect magic squares have 3 more properties that make them even more magical than a regular magic square. Here they are. First, each broken diagonal also sums to the magic sum. A broken diagonal is similar to a major diagonal, but it wraps around the edges. The center and left pictures here show this property. Each colored group of 4 squares sums to the magic constant. The second property is that each 2x2 square of 4 numbers, including wraparounds, sums to 2s, where s is equal to n squared plus 1, and n is simply the side length of the most perfect magic square. Note that this property only applies to most perfect magic squares with consecutive integers. Once we relax the requirement for consecutive integers, this property becomes each 2x2 square of 4 numbers, including wraparounds, sums to 4 over n of the magic sum. In the 4x4 most perfect magic square, this simply means that each 2x2 square also sums to the magic constant. The third property is that each pair of numbers distant n over 2 along a major or broken diagonal sums to s. Once we relax the requirement for consecutive integers, this property becomes each pair of numbers distant n halves along a major or broken diagonal sums to 2 over n of the magic sum. In a 4x4 most perfect magic square, this means that each such pair sums to half of the magic constant. In the picture on the right, each pair of numbers with the same background color sums to half of the magic constant, which is 17 in this case. The 4 diagrams here show the 2x2 square property of a most perfect magic square. Each group of 4 same colored numbers in each grid sums to the magic constant 34. Wraparound 2x2 squares are included. And now that we know what a most perfect magic square is, I can show you the method to create one. In this square, the magic constant is s, and h equals half the magic constant. First, you need 5 numbers. If you want to use this for a magic trick, math trick, you can ask somebody for their birthday to fill in A, B, C, and D. You can choose X yourself, or you can just choose all 5 of the numbers. If you want to check that this works, pause the video and do a little bit of algebra. Finally, let's see an example. Here's the most perfect magic square made from the method using the birthday of Albert Einstein for A, B, C, and D, and with X equaling 26. The birthday of Albert Einstein is March 4th, 1879. As you can see with this square, the method sometimes generates negative numbers for certain squares. Additionally, it is possible but unlikely to get duplicate numbers. Finally, if the magic sum turns out to be an odd number, then the bottom 2 rows will be completely filled with decimals. However, even with this, I still consider the method and the magic squares it can produce truly magic.